Another way to categorize the types of language is to separate them between procedural language and object-oriented language. So procedural language you can basically see as a kind of like a ticker tape that goes into a machine, and the machine just sort of runs down the line of tape. So the next instruction, next instruction, next instruction. Whereas object-oriented languages is more of like a bunch of balls in a tank, and the balls do different things.
So these procedural languages, some examples of that, we have Fortran, COBOL, C, and BASIC. They pretty much are designed mostly of variables, functions, and primitive data types, which we haven't talked about. Primitive data types, it's a very simple concept. It's just
like a letter or a number.
Right. Basically that's anything that can be expressed as a number that can retain a value. A character is a number, which we talk about later when we talk about ASCII. Of course, a number themselves, different types of numbers like floating point numbers.
A Boolean value.
Boolean value.
So object-oriented languages also include all of those, but they also include a collection of these into larger objects. So you can create a new object that contains a unique set of variables, functions, and data types, which define new data types. And you can start to build your own language.
And if you don't understand that, don't freak out at this point, please, because Brian and I will go very in-depth in the object-oriented concept later.
We just want to expose you to the idea.
Brian and I also compiled a list of methods of execution, and we believe that this is important because depending on the type of software that you're using and developing, you need to know the type of environment that you're working in. The most primitive, but also the most efficient method of execution is a compiled execution, which is when you write a piece of software and you take the code file, and then we use a piece of software called a compiler, which actually converts that code file into machine language.
So you could see a compiled program as every word that you type in a program is basically a shortcut for a larger block of machine code. So if you use a word that is a part of the language, it's just a long series of ones and zeros that get processed by the computer. So before it runs, it actually converts it. You know, it uses all of those shortcuts and builds out the file and then runs that.
And when you have a compiled file, you execute it as a compiled file, which is a little different than this next item, which is an interpreted file. An interpreted file technically runs as compiled, but it doesn't pre-compile it. The program is actually read by a program that's called an interpreter that runs through the code, and as it's executing it, starts compiling it, and then runs that compiled code.
Right. So if you get a compiled program, let's say you're in Windows, and you get an executable file, which is a compiled program, you can't open that program in a text editor.
Oh, you can,
but
you're not going to have any idea what's happening.
It'll just be gibberish. Whereas an interpreted program, if you get that file, you can open it in the text editor, and you'll actually see the programming language in the file.
Right.
And you'll actually run that through an interpreter. So you can, up until the point when you run the program, you could change that interpreted script.
Right.
After this is the framework and virtual machine execution types, where you have source code that's converted to common runtime language, which is the same across multiple platforms, and gets processed in a virtual machine and then compiled. So that's kind of complicated, but when you compile something, you compile it for a particular operating system. So you compile it for Windows, for a 32-bit processor, for a 64-bit, whatever.
Exactly.
When you run in a virtual machine, you install a virtual machine that's designed for Windows 32-bit or a 64-bit processor on another operating system, OS2 Warp, whatever. And the common runtime language, which came from your source code, can execute on any of those virtual machine installations.
Absolutely. And that's one of the, you'll see most languages have moved in this direction in modern times for, to solve the cross-platform incompatibility problems that we've had over the years. So you can write something in Mac OS and take that same code and run it in Windows or Linux or Unix or whatnot, and without having to recompile the code.
And Java is the most popular example of this. Lastly, there's emulated, which means that you can run a program on your operating system that simulates another operating system, and within it executes a program for that operating system. So, for example, you can, in Linux, run a Windows emulator that executes a program compiled for Windows in Linux.
And the beauty of that is that, what Brian is saying is all true. Now, we were just talking about frameworks of virtual machines. Well, there are situations where you have a program that is compiled for a single platform that is not written in a language that runs on top of a virtual machine. Like one example of this is, in the example Brian was talking about was in Linux, there is an emulator called Wine. And Wine will run Windows applications, so you could take Wine and install Adobe Photoshop in Linux,
Right.
and you could run it in your Linux operating system.
Other common times you see emulation is on console emulators. So some people will play like Super Nintendo on their phone.
Yep.
And things like that. So,
and you'll also see in terminal emulation, now technically this isn't a matter of execution, but if you work in a situation where you're working on mainframes, you may encounter this.
So I hope this has been a helpful overview of the kind of the core concepts of languages. And thanks for watching.
Yep, we'll see you in the next one.